created a project called Threshold Filter. I'm gonna add a vision module to my project. I'm gonna acquire the image from a Gigi camera, and I'm gonna apply a threshold to that image. So let's see how we can do that. First thing I'm gonna do is to add a PLC. Then you need to go to your solution and show hidden configurations and show vision configuration. This will only be available once you installed TwinCAT Vision in your machine. So when you click on that, now I have it here. So I'm going to add a new item. Call it application 1, doesn't matter. Then you don't need to have a camera. If you don't have a camera, you can use file source. And then you just point to a directory of images. But I do have a camera, so I'm going to use this Gigi Vision camera. Hit OK. You do new. New again. It's going to detect my Ethernet adapter. Hit OK. Okay. So in my IO tree now I have my Ethernet adapter, and under Vision here I have a camera. So I'm going to scan to discover devices. So this is not allowed when you're in run mode, so let me cancel, go to config mode. I can come here, and so I went to camera, click on this wheel, then discover devices, and this is very important. So the camera has its own IP address, and you need to make sure that you're in the same subnet. So this IP here is within the same subnet of my Ethernet adapter. So I'm going to hit OK. And it should take a moment to connect. So now it's online. Some of the parameterization of my camera is incomplete, but I'm not going to bother about that now. You can do a quick test to see if your camera is working. If you go to Configuration Assistant and hit Start Acquisition. So this is my image here. It's kind of laggy, but I'm just showing this the back of slice, the box of a back of slice. So we can stop the acquisition here. And there are other things that we're going to see later in other episodes, but for example here you can do the calibration. You can do both intrinsic and extrinsic calibration, and then you can use these matrices in your project to do the mapping between your robotic system and the camera. I'm gonna just ignore this for now. Let's focus on the very, very basic things. So now that we have this part set up, in our PLC project, we're gonna add our reference. So you see 3_vision. Good. There's one last thing we need to do, and this is very, very important. Well, we don't need to do it right now. Let's first declare some stuff here, and then we will link a variable to the image itself. Okay, so let's start with the hResult. So the hResult is what the function returns. Every time we call a vision function from this TwinCAT Vision API, the only thing that the function is returning is a code telling you if the operation was successful or not. Sometimes it gives you the type of error that you're getting if it's not going through. The other thing we're going to need is a FP camera. And this one is going to be of type FP_VN_simple camera control. Okay, looking good so far. Then we gotta get the state of the camera. By the way, this FB camera, this is what we're gonna be using to be getting the image from the camera, and then the E state tells the state of the camera. So the E state variable is gonna be of type etc vn camera state. Then we gotta get our image. So we're gonna get the image using FB camera. That's gonna be our input image. So we're gonna call it IP image in. And the type of this image is ITCVN image. I also gonna need another image for the process image, so we're gonna call it processed image, and it's also a IT CVN image. Then I need a displayable, couple of displayable images. I'm gonna do two of them, one for the processed one and one for the bare one, the raw one. One for the processed one and one for the raw one. Now the code starts with us getting the state of the camera. So E state equals to FB camera dot get state. Then we can do if is E state equals to DCVN underscore CS underscore error. Then HR E camera dot reset. So if the state of the camera, my bad. Okay, so we get the state and we evaluate the state. If the state is in if the state of if the camera is in error state, then we reset it. And as always, we get the result of this call and we put an HR. So this way we can evaluate if this call was successful or not. Okay, so this is the first part. Then else if the state is lesser than TCVN underscore CS underscore query. Then we start acquisition. So now if this state is not acquiring but not error, then we start acquisition. Now if is state is acquiring. If we are in this state, then we We're gonna get the image, the camera dot get current image, and we're gonna accumulate that image inside IP image in. Now we can evaluate succeed. So now, once we call this, we evaluate if get current image was successful and the image is not zeros. If this is true, then we can call our function. So I'm gonna do here a simple threshold function, threshold filter. Maybe under segmentation, image segmentation, threshold. Super simple. So this will get the value of a pixel, and if that value is above a certain threshold, it will turn that into white. If it's below that threshold, it's going to turn into black, or vice versa, depending on the threshold type that you selected here. Well, here there's an implementation. I'll just copy this, and I'll paste it here. My output image is called processed image. So I'll change that. Okay. So I get the image from the camera. If that process was successful and my image is different than 0, then I call this threshold function where I'm passing the image that was acquired. The result is stored inside IP processed image. The threshold is 128. The max value is 255. It's a binary threshold, and the result goes through HR. Now the last thing we gotta do is display that image. So I'm calling this function transform into displayable image. Transform into displayable image. Then the source image and the destination. So my source is IP processed image, and my destination is IP processed image to display. Oop. And HR. Okay, so now let's build this. You gotta build it because now we're gonna link the camera. I want to ignore that. I don't care. It has to do with that warning that we saw in the very beginning, the camera configurations. This camera that I'm using has some internal config that's not matching exactly what I have on the TwinCAT side, but I don't care. It's not going to influence anything for now. Okay, so now we're gonna link the camera to this component so we can access from the PLC. So here we're gonna go to our PLC instance, then symbol initialization, and this element here is in my PLC code, and I'm gonna link this element to the camera image provider from my vision application. So I'm linking them together. So now I should be able to download this and run this thing. Okay, I forgot one thing before we test this. Let's copy this line. Let's also populate this variable here. So this guy here, one is going to be the processed image, and the other one is going to be the raw image. So this here is the raw image. This one is the thresholded image. So we're going to be flipping between IP processed image display and IP image in display. So not great names, but you get the point. So we're gonna activate this configuration. All right. Then we go to TwinCAT, Windows, ADS Image Watch. And from here, we can select the image in display, which is our raw image, and IP processed image, which is the thresholded image. So this is the raw image. And you can see it's my hand here. And this is the thresholded one. So now let's change this. Change this to like 80. I wasn't really glad with the result of the threshold of the previous exercise. You could see a lot of gray, and that was happening because of these weird artifacts with the image, these very small lines. So we were having the impression of having these gray areas in the image, but you can actually correct that by using a Gaussian filter, and the Gaussian filter is going to smooth out the image, and then once you do the Gaussian filter, you can just apply a threshold like that, and then you're going to have a way crispier result. However, I'm running this program from my personal computer, so I don't have that much memory allocated. If you just try to run this straight up from a computer like the way I'm doing it, you may run into issues. So if that's the case, you need to go to your real time and change the router memory allocation. So I increased mine. And remember, when you increase this memory, you're taking out from the RAM of your operational system. So you want to be conservative when you increase this number. So coming back here, I also added this variable, which allows me to force the threshold value. So I'm going to do a test here. Let's do 80. So you can see that I can change threshold on the fly. You can also make it darker.